Okay, this lesson is on some of the properties of real numbers that we have. The first property is the distributive property, and it looks like this. I'm going to multiply that a to the b, and then I multiply it to the c as well. We use this property quite a bit. I'm sure you've seen it before. I could also have the a written in the back here, but I get the same result, ab plus ac. An example of using the distributive property would be this. Negative 4 times p minus 5. I'm going to distribute the negative 4 in to the parentheses. That would be negative 4p. And then negative 4 times a negative 5 would give me a positive 20. Now, you can extend the distributive property to more than just two terms in the parentheses. Another example of this would be 3 times the quantity 2p minus q plus 5r. I'm going to distribute the 3 in. 6p minus 3q, and then 3 times 5r is 15r. Let me fix that mistake. Plus 15r. There we go. Okay, so there's a couple examples of using the distributive property. Next is our inverse properties. We have one for addition and one for multiplication. For addition, we take a plus the opposite of a, we get back 0. Or if you reverse that, negative a plus an a is 0 as well. Example would be 5 plus negative 5 equals 0. Or if you write it backwards, they equal 0 as well, doesn't matter. And we would say that a number and its opposite, such as 5 and negative 5, 5 and negative 5 are opposites. Some books would call them additive inverses of each other. There's my example. We also have inverse properties for multiplication. If we take a number a and we multiply it to its reciprocal, 1 over a, then we get back 1. 1 over a times a is also 1. Doesn't matter which way you do it. So this is our inverse property for addition, and this is our inverse property for multiplication. An example of that would be, let's take the number 3, multiply to its reciprocal. You just put a 1 over it, 1/3. It's called the reciprocal. And that will equal 1. What is the reciprocal of negative 1/5? Well, if you flip over the negative 1/5, you get a negative 5. So negative 5 is its reciprocal. You multiply those together, you get 1. So any time you multiply a number to its reciprocal, you always get 1. Let's do one more example of that. What would be the reciprocal of negative 2/3? What do I have to multiply it by to get positive 1? I need to multiply it by negative 3/2. So these are reciprocals of each other. Okay, next property is the identity properties. And once again, we have one for addition and one for multiplication here as well. If you take any number a and you add 0 to it, you always get a back. And so 0 is what's called the additive, abbreviate there, the additive identity. We have a multiplicative identity as well. If I take a and I multiply it to the number 1, then I get a back. And so 1 is the multiplicative identity. 0 is the additive identity, because adding 0 does nothing. And 1 is the multiplicative identity because multiplying by 1 does nothing. The next property is the commutative property. And once again, we have one for addition, one for multiplication. A plus B is equal to B plus A. In other words, it doesn't matter which order you add. An example of that would be 3 plus 5 equals 5 plus 3. The commutative property is what allows us to reverse the addition if we want to. Either way, 3 plus 5, 5 plus 3 is going to give you 8. Multiplication works the same way. A times B is the same as B times A. An example of that would be 3 times 5 is the same as 5 times 3. It doesn't matter which way you multiply, you're going to get the same result. The next property is the associative property. And yet again, we have one for addition, and then we're going to have one for multiplication. For addition, it's A plus the quantity B plus C is equal to A plus B quantity plus C. And what this is saying is that addition you can add in any order you want. Doesn't matter what order you add your numbers in, you're going to get the same thing. For example, 3 plus 4, 3 plus, in parentheses 4 plus 7, would be the same as 3 plus 4, then plus 7. You can check yourself. Either way you do this, you're going to end up with 14 on both sides. Multiplication, A times the quantity B C is equal to A times B then times C. It does not matter in what order you multiply, you're going to get the same thing. For example, 2 times, in parentheses, 3 times 5. So that means I'm going to multiply the 3 and the 5 first to get 15, and then times 2 would give me 30. But that's going to be the same as 2 times 3, then times 5. The order in which you multiply isn't going to matter. You're still going to get the same result. That's called the associative property for multiplication. Now the multiplication property of 0. As you know, you take any number and you multiply it to 0, you're going to get back 0. Or 0 times A equals 0 as well. Doesn't matter what order you do it in. And so an example of that, 3 times 0, of course, is 0. Or negative 1/2 times 0 would be 0. And even 0 times 0 is 0. This stuff we kind of already know. Okay, next. Combining like terms. This is something that we do a lot in algebra. So let's just review it real quick here. 3x plus 2x. Now, if I use the distributive property backwards, I could actually write it like that. Notice that if I distribute the x in, that would be 3x plus 2x, which is what I have above. Now that's 5x. So 3x plus 2x is 5x. I usually don't show this step in the middle. We usually just add 3x and 2x to get our result 5x. Now I should actually have written up here first is that terms, or like terms here are terms with the same variables to the same exponents. So I could combine the 3x and the 2x here to get 5x, but I couldn't combine 3x plus 2x squared, and that's because they're not like terms. One is an x and one's an x squared. It's not the same exponent. Here's another example. 2x squared plus 7x squared. Those are like terms. 2x squared plus 7x squared would give me 9x squareds. Notice that I skipped the step that I showed here. We usually don't show that step. 4x minus x. You want to think of that minus x as 4x minus 1x, and that would give us 3x. Here's a couple more. Example. 12b minus 9b plus 4b minus 7b plus b. There's a lot of b's in there. We'll start on the left and work our way over, combining all these like terms. 12b's minus 9b's is 3b. 3b plus 4b is 7b. 7b minus 7b is 0. And so we just end up with 1b here. 1b. Here's another example of combining like terms. Okay. I first have to distribute that negative 5. Make sure that you do take the negative sign with it right there. So this is going to be 3x plus 4 minus 5x and then minus 5, like that. Okay, now that I have gotten rid of the parentheses, I can combine my like terms. I've got 3x minus 5x right there. That's going to be negative 2x's. Now I've got 4 minus 5. I guess I'll do some 2 steps here. That's a negative 1. But then I also have that minus 8 on the end as well. I can combine those. Negative 2x minus 1 minus 8 is going to be negative or minus 9. And so my result is negative 2x minus 9. Here's another one. Okay, I have parentheses in here as well. That negative sign there, I'm going to think of that as a negative 1, like that. And just like I did in the previous one, I'm going to take that negative 1 there, and I'm going to distribute it in, like that. Oops, let me change my color here. It's going to be 8 minus 3m, then minus 2. Combine your like terms. I have an 8 and a minus 2 there, which is going to be 6 minus 3m. Okay, and one last example in this section here. I got 3x times 5 times y. Well, this isn't really a like term problem here. It's all multiplication, and so all I'm going to do is do a little rearranging. 3 times 5 times x times y. Remember, you can multiply in any order you want, doesn't matter, so I can rearrange them like this. That's going to be 15xy. Okay, and there's our quick review on some of the properties of real numbers that we have.